you don't get. So for a start, with this notation, I want to say with base point, and also.
Yeah, so match from S1 to S1 with base point, for instance.
Yes, I mean, but that doesn't really factor if I'm talking about a complex version.
Okay, but I'm happy.
Okay. Okay, and so then I guess the corollary is putting these guys together. So I want to put this one together with this one. So I should be getting n minus 1 Yeah. So I guess I pass from this side to this side. So this side, remember, is meant to be thought of as vector bundles over, I guess, n sphere. And I pass to this side by cutting the vector bundle in half, noticing that because the two bits are contractible, both must be isomorphic to trivial bundles, which means that I've got just a single map gluing them, and this is going to be the clutching function. And going the other way is the clutching function construction. Okay, so this tells us that we should be very interested in things like this. This was going to be one of the exercises of it, in some cases at least, finding the stable ranges of these things. So for n large, we should be getting Okay, so you can calculate some of these in the lower down ranges quite nicely using sort of exceptional homomorphism, or exceptional isomorphisms to known topological spaces. Yeah, okay, so I guess maybe the next thing where it's at base point is to make that clear. So really I could just be putting an S everywhere here. Except that I want to be careful because in the case of 1 here, this gets pi naught of ON, which I do want to be there too. Yeah, so like I say, in small cases this is quite nice. So let's say n is 3, for instance. So yeah, and then I guess this, if I put, I haven't talked about that yet. Okay. So the calculation is nice and low dimensions. So for instance, if I have n is 3, then okay. So let's look at that guy. So I'm looking at pi, I guess pi 1 over 3, and then that's going to be pi 1 of SO3, so we're calling it base point. to get the stable part, so saying that this is true for n large forever, you have to use sort of vibration sequence like that's what you have to do for this one. So then there's this vibration sequence. So I think it must be something like this is actually off the cuff. I haven't written this down on the paper, so I'll tell you in the second half of the talk. So some kind of sphere, and then you can take long exact sequence of this vibration. To n?
The last coordinate.
Oh yeah, like so another example of how this is easy is we take capital N is 2, then SO2 is the circle, and then okay, so that's why we need n large, because it hasn't stabilized yet. Okay, so I'm going to settle that. Okay, so I'm just going to say one last bit about stable ones. Okay, so if I've got two vector bundles over the same base space, so remember that I can think of that as maps like this. I don't want to do that. So let's say that's the BO chain. That's BO. Then there's a operation called a width sum. So on the base space of the manifolds, I just, I guess I take it at every, so this is the new notation for the total space of the manifold at the fixed bundle over X. So I take a direct sum of these stats. Which means like, if we do this pointwise, fiberwise, yeah, fiberwise. I mean pointwise on the base, fiberwise. So this should now be a J plus K plane bundle. So upstairs in the classifying space world, this corresponds to taking a product. So and you can show that this is contained in well, I mean, you have to show this is it's definitely a J plus K thing, so somehow putting these maps together should be a map into this thing, but I think you can show on the level of classifying spaces of G groups that this is always true. keep going. So, definition. So using this, I can form a directed set, and again, take another direct limit of here n, and find that to be the stable classifying space, and then similarly, the stable classifying space. So I guess every vector bundle like this represents a map of X into one of these stable spaces. But we sort of want to identify it with every stabilization up to infinity. Yeah, so I think that was more or less what I wanted to say. So there's just like again, I want to do one of these one-to-one correspondences, which is now stabilized multiplicity classes. So I'll say what that is in a second. Of the vector bundles, real, I guess. So one-to-one correspondence with homotopy classes. So two vector bundles are stably isomorphic if they're isomorphic after performing this stabilization operation. So I guess I want to say, let's get this right. Stabilized with different ranks of trivial bundle on either side of the equation. So, I guess. Okay, so I think I'm going to stop there, and then after the break talk about how this is actually related to surgery, which has been a bit opaque so far.